Hello everyone. Today we will be doing the experiment on preparation of Benzil. Here is the glassware we will be working with. From left to right is a 5 ml reaction vial, a spin vane, and an air condenser. Our reactant today is the benzoin that we had prepared on the previous day. In this video, our TA Goshu is measuring out approximately 0.3 grams of benzoin from the benzoin product vial. Then we transfer the reactant benzoin into a 5 ml reaction vial. In the reaction vial containing benzoin, we put the spin vane. Then using a mechanical pipette, we have to pipette out 2 ml of the copper to acetate solution. Since the maximum volume measured by this mechanical pipette is 1 ml, so we need to do 1 ml times 2, so 1 ml twice. Next, attach the air condenser and screw it in place tightly, and then place the reaction vial with the air condenser attached onto the aluminium block. Make sure that the reaction vial is secured in place using the clamp. Then switch on the heat and the magnetic stirrer. The heat is switched on and the temperature is a little less than 100 degrees Celsius. This reaction mixture will be left to reflux in 60 minutes and we will be observing the change. After 60 minutes of refluxing, we stop the heat and then remove the reaction mixture from the hot plate and place it on the bench to cool to room temperature. Then using a Pasteur pipette, we are going to take 4 ml of DI water and additional mLs of water in measuring cylinder and place both of these containers in an ice bath to cool. When the 4 ml of DI water in the beaker has cooled down enough, we are going to pour the contents of the reaction vial into the beaker. But before pouring the contents, we have to take out the spin vane and we need to use tweezers for that. Once the spin vane is out, we are going to pour the reaction mixture into the beaker. Then using a Pasteur pipette, we use more ice cold water in order to wash the insides of the reaction vial. As you can see, there is some degree of cloudiness in the beaker, which means that some amount of crude product is formed. The TA is swirling the beaker in order to make sure every part of the reaction mixture comes to contact with the ice cold water. So when we are sure that we have a generous amount of product formed, we are going to vacuum filter the solution using a hard. The product is kind of yellowish in color. As the crude product is being dried by vacuum filtration, we are then going to proceed to the next step, which is recrystallization. We will pre-weigh the beaker in which we will transfer the crude product, and this is the same beaker where recrystallization will be carried out. When the crude product has dried enough, we are going to transfer the crude product from the Hirsch funnel into this pre-weighed beaker. Then we are going to weigh the beaker again with the product in it. Our next step is recrystallization. Recrystallization involves dissolving the crude product in the least amount of solvent possible to make a saturated solution. In our experiment, our solvent is ethanol, so we heated up ethanol on the hot plate. The beaker on the left hand side contains pure ethanol, and we'll be using this hot ethanol to dissolve the solute. The TA is stirring and trying to make a solution with the least amount of hot ethanol possible. When all the crude product has dissolved, we are going to leave the beaker on the bench top in order to cool down. Then we will transfer the cooled down beaker into an ice water bath to cool down further. When the beaker has cooled down enough and there has been some level of crystal formation, the TA takes the beaker and scratches on the walls of the beaker using a glass rod in order to further facilitate the crystallization process. Then, as usual, we vacuum filter the solution in order to collect the crystals. The TA pipettes ice cold ethanol into the beaker in order to retrieve as much product as possible. Then this recrystallized product is left in the Hirsch funnel to dry. The product is yellowish in color. While this final product is drying in the Hirsch funnel, we are going to take the mass of the vial in which we will transfer our product. Next step is product transfer. So we will stop our vacuum and then take the Hirsch funnel and then transfer the product into the product vial that we just weighed. So this is the product that we will be doing the characterization of. And we need to take the mass of the product, and we need to take the IR, and we need to take the melting point of the product. So here is the vial with the product, and we are taking its mass. Next is to measure the IR. So we start off by taking the background, as we have seen. The stage is clean. And we are going to load the sample onto the stage. So this is Benzil that we have synthesized and purified by recrystallization. So we have to cover the little peephole on the stage with the Benzil. Then we are going to cover the sample using a small square piece of paper and then turn the knob and screw the knob in place. Then we are going to click on collect sample, name the sample Benzil, click OK. And then we are going to wait for 8 scans to be completed. Once the 8 rounds of scanning completes, You add it to a new window, click yes, and then name your sample, Benzil, and then find peaks, and then print. Next step is to collect the melting point of the compound that we have synthesized. So we are going to poke on the compound so that there's 2 to 3 millimeter of the compound in the open end of the tube, and then we are going to drop it through this tube several times so that all of the compound collects at the bottom. Then place the tube in the melting point instrument and click on run. When you press on run, and then as we have seen before, we are going to slowly raise the temperature of the compound using this melting point instrument. And we can choose what increments the melting point instruments runs. I think this was set at 6 degrees Celsius per minute. And then we are going to see through this lens when the compound melts. So whatever range, the compound is going to melt over a range in degrees Celsius. So whatever range it melts, so we have to report that range in our lab report. So after every single experiment, we need to clean up our workspace, we need to clean our fume hood, and we need to clean the bench space. And we will keep the hot plate stowed away. And we will also clean up every single glass apparatus that we used using acetone as is in this waste fume hood. And we have to throw away every liquid waste in the liquid waste bottle, the huge jar that you see, and the solid waste in the small beaker. Yeah, and every single the glassware that can be thrown away, that's in there, whatever is disposable and or any broken glass will go into the broken glass container. So when you're ready to leave the lab, you should have the fume hood cleaned of everything, and the bench space as well. Everything should be clean. Everything should be dismantled and stowed away. So that was it, guys. We have synthesized the compound Benzil from the starting material benzoin with the help of copper 2 acetate solution. And then we also took the mass and the melting point and the IR for characterization of the resultant compound. We will be saving this product for later conversion to tetraphenyl cyclopentadienone, which is a later experiment in this course.